Okay, so today we'll be talking about transistor amplifier. First thing, we're talking about capacitor. That are very, very important. Okay, the capacitor. Okay, when we connect to the AC, then capacitor will get some resistance, and that's what we call capacitor reactant, IC, and will be calculated by the formula IC equal 1 over 2 pi times F times C, where IC will be in ohm, pi 3.14 joule, F has to be in hertz, and C will be in farad. Okay, so if you get a good coupling, then IC will be less than 0.1 R. The next thing, capacitor will be shorted. Okay, just a wire. Or the capacitor can be open. That means no DC current can go through. And what we said for AC analysis, the capacitor is shorted. For DC, capacitor will be open. That's only telling you capacitor not allow the current DC to go through it. Okay, when they full charge. Now we're talking about amplifier analysis. First thing, you have to perform complete DC analysis. Without the DC power supply, transistor not working. So that's why guarantee any calculation for DC we have to do. Then short on coupling and bypass capacitor. So the capacitor will be shorted for DC. Visualize on DC supply voltage at AC round. So that's why in the AC you didn't see any more DC voltage. They shorted to round. Replace the transistor by its pi or T module. They get a different module, okay, for AC. Draw equivalent circuitry for AC. Now, in here you can see this is the capacitor we already done for DC. Okay. However, for AC, now capacitor will be look like. That means you get a from collector you get a current IC coming in. At the base, you get the IB coming in. And from the base to the emitter, now they get a resistance, no longer diode. Okay? Before you get a diode for DC, this is a diode here. However, AC, they turn out to be a resistance that are internal. And this resistance calculated by this formula. R prime E equal 25 millivolt divide IE for the transistor. That formula. Okay? And now, if you looking into the base, okay, then you get the input resistance G in base. They will be equal VBE. That means voltage from the base to the emitter divide IB. Okay? Or VBE equal IE times R prime E. The thing is the current flowing here, IE. And the resistor R prime E. Okay? And then J in base will be equal IE times R prime E divide IB. Finally, that's what you want to get here. If you want to calculate the input impedance, they will be beta times R prime E. Now, you get the input here, you get the output here. And the gain is 200. So basically by definition, the gain equal V out divide V in. We already know that. Now, third thing, we're talking about CE amplifier. Okay? This circuitry will be a CE amplifier. See, what happened? Input signal to the base. This is the input here. Your voice here. Apply to the base. Okay? So, basically, that will be VB. Okay? And that will be VC. And that will be VE. Okay? Input. Oh man. Oh man. They give me a problem again. Okay. Ha, man, play around with that. Okay.
There's a sound really, really annoying. There's a sound.
What? Can you hear me?
Yeah, now we do.
Yeah, we can hear you.
Okay, now this is the input here. That means when you're working on the lab, that will be a generator applied to the base. Output from collector. Input and output will be 180 degrees out of phase. Okay, the important to you. That means when you're looking into the circuitry, you know that will be CE amplifier. Okay? And the input and the output will be opposite, 180 degrees of phase. Now, talking about C1. C1, the name will be DC blocking or AC coupling. What that means? That means no DC from the source go into the base. And sideways here can go to C1. Okay? So that is telling you C1, DC blocking, AC coupling. C2, you understand at the collector you get 2 voltage, not only one. First thing you get a DC voltage, then you can get a AC voltage. And they going out to the load here. You understand the load here just a speaker. So you don't want any DC from the collector go to the speaker. So this capacitor will be also DC blocking and AC coupling. That means they allow AC to go, but not DC. And the last one, C3. C3 they call a bypass capacitor. What that means? Basically, you get a sine wave coming in. And this you get a sine wave. Okay? And this one also, you get a sine wave, only thing is the opposite. And this is supposed to get a sine wave, the same, like the base. However, C3 will be shorted for AC. So that means the current IE remember, if we're using capital, that's the DC current. If we're using a lowercase letter, that will be AC. So capacitor C3, they will be shorted for AC. That means they look like just a wire. So the current IE, they will be shorted to the route. Okay? They not go to RE. Okay, so the C3 they call what? Bypass capacitor. Telling me C3 bypass what? What C3 bypass?
AC.
bypass, that means at the point at meter here, IE will be go this way. Okay? Go to route. They're telling you they bypass IE. That means the current IE cannot go through RE. That's why they call bypass. And bypass again, bypass resistor RE. And later on you can recognize if without the capacitor C3, IE will be go this way. Okay? With the bypass capacitor, current will be go this way. With the bypass capacitor, that will be make the gain of the amplifier higher. Okay? That is the purpose. Now, basically, this will be very good picture. You can recognize the signal when you're working on the lab. You see, this is the sideway. And C1 is a bypass capacitor. So that's why this sideway will be go to here. So basically at the base here, you get two signals. You see that? First thing, you get 1.8 volt DC. And also you get this sideway. So now I try to draw bigger so you can recognize. This is a 0 volt, 1.8 volt. You can see 1.8 volt here. Okay, and now you get a sideway 100 microvolt. So if you're looking on the scope, you can see. Okay, they want to measure the V peak to peak, okay, of this signal. You see, you cannot measure. If you want to measure the V peak to peak for this one, how can we do? Who knows? Let me know.
You adjust the sine wave to make it larger.
No, cannot.
In the screen, are you talking about on the oscilloscope?
Yeah, they will be supposed to display on oscilloscope and you will look like this signal.
Yeah, you would have to stretch it out.
How? You move it out?
by the dial on the oscilloscope.
What you set up the oscilloscope in order you can measure this guy. Otherwise you cannot. The thing is that a 1.8 volt is too big and this 100 microvolt too small. How can we measure this small signal here?
You have to stretch it out.
No,
Oh.
just telling me you're using oscilloscope and I want you to measure that one 100 microvolt here. Very small. However, at this point you get two voltage, 1.8 volt DC and also 100 microvolt AC. I want to measure this signal here. Who knows how to do? Nobody know? I telling you. First thing, you have to know how to remove that guy. 1.8 volt DC. Okay, remember, set scope. AC coupling. Okay? If you want to measure the small AC with the DC, then you must be set the scope to AC coupling. Okay? When you set AC coupling, they remove this DC. So that's why you can see that sideways. The thing is when you're working on the oscilloscope, you can set DC coupling, AC coupling. Okay? If you measure DC, that will be telling you. Okay? That's a way you can measure signal. AC. Also the same. You get 100 microphone here. They amplify the get signal a little bigger. However, at this point, you also get 6.04 DC voltage. Okay, so you see that 6 point in the middle, and this is the sideway. So you have to set the AC coupling. They try to remove 6.04 volt. Display only this sideway, so you can measure it. And also make sure input go up, output go down. Okay, input going down, output going up. That's telling you input output will be opposite or 180 degree out phase. Okay, and now at this point here, DC 1.1 volt. However, if you measure the signal, you don't see any signal. Okay? The thing is, they short it to the ground. So at meter, if you measure AC, they will be 0 volt. Okay? So that telling you, if you measure the output here, okay, then basically you get sideways, no DC here. So that's why easy to measure. Okay, first thing, any question on that? Comment at meter. If you see on this circuitry, you must telling me this is a common at meter. Input applied to the base, output from collector. C1 will be DC blocking or AC coupling. C2 same thing, DC blocking AC coupling. C3 bypass capacitor. What capacitor bypass? They bypass 1 kilo ohm here. That means current IE cannot go through 1 kilo ohm. So if you measure AC at the 8 meter, they will be 0. DC, they 1.1 volt. Okay, anything else you want to ask him? Nothing? Now, let's go to GT module. In order to calculate the AC, okay? And you understand here, this is the base. This is the collector. And this is the ammeter. Now, that one have to be this way. Okay? Now, remember, from the base to the ammeter, before you get a diode, for AC, no longer diode. Substitute by resistor. R prime E equal 25 millivolt divided to IE. Okay? So, first thing, we have to know, if you at the source right here, there's the input here, looking into the amplifier. Okay? That's what you're looking for. Either way you can say R in. That means input resistance. Or they call a Z input impedance. Either one, same thing. So if you're looking into that, into the amplifier, what you get. Now, I try to make sure you understand. When you go to the AC module, what 10 volt connect you? If you're converting this circuitry to AC, my question is, this is a 10 volt where you connect to.
thầm chào nhau thôi rồi vĩnh biệt người ơi, ngày buồn đã tới, ngày giây phút tôi xa người, tình đã úa nhau, mình đã thôi.
Oh man.
So, Professor, you're saying what is those 10 volts getting connected to, or that's what you're trying to say?
Okay, I try to repeat it. I converting this circuitry to AC circuit. When you get an AC circuitry, then the transistor now will be look like. Okay? And then you can see this is that transistor AC. But my question is, 10 volt DC here, where we connect, how do we connect? Whatever you think, just let me know.
Bipolar transistor?
Now, I talking about 10 volt DC right here.
Oh,
If we converting to the AC, and you don't see anymore 10 volt, that's why you see right here, you don't have any 10 volt. That's an AC module. My question is, where 10 volt go?
The ground.
Exactly. Let's see in here. Somewhere I know. You see right here. Visually only see supply voltage at AC route. That means any DC voltage will be round AC. Okay, so that's why. Now, if you round that one, okay, can you tell me 10K, 2.2K will be series or what? I'm talking about 2.2 first. 2.2 connect to the base and connect to the route. And 10K, one side connect to the base. The other side now connect to the route. So that's why you can see R1, R2 now will be in parallel. Is it correct?
yes.
Okay, make sure. Anything confusing, just bring it up. Okay, now I try to draw. First thing, 10 volt will be round. So 10K one side to the base, the other side to the round. So that's why they parallel with 2.2K. So R1, R2 now in parallel. Okay. Telling me 3.6K here and 100K here. 3.6K, this is a collector. One side collector, the other side connect 10 volt. However, now they will be round. So they will be go this way. That's 3.6. What happened to C2?
Sort it out.
For the AC, they
Right.
will be AC coupling.
Coupling.
That means this one will be shorted. Okay, you didn't see any capacitor here, so that's why. Now you see RC, RL in parallel now. Okay, try to understand we're converting from the DC circuit to the AC voltage. If you're looking into the output here, okay, they will be G out. Or in this one, they will be RC. Output impedance. When you're looking into from input to the amplifier, whatever resistance you get, that's what they call a input impedance or in, same thing. When at the output here, you're looking into the amplifier, see what resistance you get, that's what they call a output impedance. Or in this one, they call RC. Okay? RC means output impedance. And the gain will be equal V out divided to V in. Try to understand one amplifier right now, common admitter. Then later on, you can get common collector, common base. They will be more easy. Okay? If you really understand the first one. Any question here? Example number 1. This is a common admitter. I know that's a common admitter. The thing is you get the input sideways, go to the base. Output from collector. Input up, output down. That means output input opposite or 180 degree of phase. Okay? C1 blocking capacitor. Okay? DC blocking.
Mr. Pham,
Okay.
your iPad needs to be plugged in, or you're gonna everything's gonna shut down on you real soon. Either that or it's your computer. One of them only has 5% battery on it.
Oh. You mean I have to shut down one?
No, I'm saying you have to plug it in so it can get a charge.
Plug it in.
Is the iPad.
It's the iPad? Okay.
Think so.
Yeah, look at the charging or the battery on your iPad.
Yeah, iPad's still charging.
Yeah, but do you have a charge on it? It's something it says it only has 5% left.
Oh,
You need to plug it in.
thank you. I forget to connect into charger. Man. Why they give me trouble? Yeah, thank you. I do it. Hello. Okay, thank you.
You're welcome.
Okay, now on this will be CE amplifier. C1 DC blocking AC coupling. C3 DC blocking AC coupling. C2 bypass. Okay? And in here they given you 2 beta. Beta is what? Beta is the current gain of the amplifier. So if you calculate DC, you're using 150. You calculate AC, you're using 160. Okay? Now see what they asking. Now, what they want, they calculate the VB, VE, VC. Now you do it for me. Go ahead and do it, telling me what you get. Who get the answer? Let me know.
Two point eight three.
What you get?
2.83.
2.83.
83.
Who else get the same?
Okay.
I do. 2.83.
Okay. So look like good. Next one, VE. Should be 2.
.13.
2.1.
What you get for IE?
.0038.
Give me the millivolt.
Oh. 3.8.
Perfect. Milliamp. IB. Beta equal 150. IE, you get 3.8. Divide.
.025.
0.025, that's what you get.
Yeah. 252, but
Yeah, that's okay. That's good enough. And IC, 150 times 0.025.
3.775.
Milliamp. VC, 'VC will be VCC. VCC 12 volt. Minus IC. One K.
Okay, 225.
Is it 8.2?
Yeah,
Yes.
Last one. VCE. VC minus VE.
6.07.
6.07.
07.
So that is the DC calculation. And hopefully later on, if you need to doing a calculation for DC, will be no problem. That will be a good for technicians and also will be very basically for engineering. Okay, any question? You get any question on this DC calculation? If it's not, you'll see what. Okay, now that's what they want you to calculate the AC. You
Okay.
see that AC, you don't have any more VCC. They will be round. Okay? So that AC will be round. Okay, let's see what they want. They want to calculate the R prime E. That means this resistor internal equal 25 millivolt divide IE. You do calculation to see you can get 6.58 ohm or not. Anyone get 6.58? Is it you do that calculation?
Yes. 0.58.
Is it you get 6.58 ohm?
Yes.
Okay, so that answer okay. Now, R in, that means if you're looking into the amplifier, you want to get the resistance, they call it R in. Or G in equal beta AC times R prime E. Calculate to see you get 1.1 kilo ohm. that are in base. That means from the base to the round, you get a resistor. That's what they call R in base. You're supposed to get 1.1 kilo ohm.
Question, Mr. Graham?
Yeah,
Over by the diagram, it says beta AC is equal to IB.
now beta
No,
AC.
beta AC is IB equal IC. Up top in the red. Is that right?
Yeah,
So the IB and the IC in this format is the same.
yeah, almost.
Okay. Is that something that's given or what?
Now normally they're using only one beta. However, on this problem they try to separate beta for DC and a beta for DC. So if I say
No, you said
beta
DC.
AC,
You said DC twice. So okay. What's the difference between beta DC and beta AC?
no,
What
that's nothing different, just a little different value. Instead, you're using beta DC for DC calculation.
and beta AC for AC calculation?
Exactly.
Okay, now, so beta AC and beta DC, is that something that's given by the manufacturer?
Exactly.
Okay, thank you.
We not make anything on that given when they build it. So you get that 1.1 kilo ohm. Okay, that is in base. And now they want C in. That means they're looking to the input here. See how many more resistance at the base. How many more? Here. You see that? They get R1 parallel R2. Okay? And also, now they want to calculate another R. That means from the base to the round.
R prime E is in parallel as well.
Exactly. That will be R in base. So basically, you can get 3 resistors right here. They show you right here. R1 parallel R2 parallel R in base. Calculate that for me.
You got your little pop-up screen here. Oh, there it is. Now you asked for R in base, Mr. Pham, but once again, you got R1, R2, and R prime E. And then, so what's the difference between R in base and R prime E?
R in base and what?
R prime E.
R prime E. Okay, R prime E, that's the internal of the transistor. Okay, they not calculate into that. They try to looking at the base, how many resistors. You get R1 parallel R2 parallel R in base, not this guy, not this guy.
But it's connected in parallel, correct?
R1. Okay, you
No,
looking,
no, no, no.
you looking in, you looking into it. It look like they parallel. The thing that is the base and that is the ground. However, total resistance internal input resistance will be R1 parallel R2 parallel R in base. And if you do a calculation right, you get 873 ohm. Okay, 873 ohm. Now, they're looking for output resistance. And if you're looking into here, okay, output resistance, that means you're looking into the amplifier. You're looking this way. That's what they call a Z out. How many resistance you see?
Mr. Pham, can we go back to the previous page? I mean 10, page 10. I want to ask a question real quick. On the rim base, can you show the math in that? The BAC is 160, right?
Yeah,
And the RE
R prime
Oh.
E.
is 6.58. Okay, I got it. Never
Okay.
mind. Yeah.
Yeah. Okay, now we're looking for output impedance, Z out. That means you're looking into the amplifier. How many resistance you get?
When you short out the capacitor, it's RC in parallel with the load RL, and that'll be Z out.
Perfect. That means this will be shorted, right?
Right.
Okay, and this 12 volt, when you change to AC, they will be ground. So that's why RC parallel RL. Okay, so RC output resistance equal RC parallel RL. That means 1K parallel 5K. So you're using formula 1 times 5 divide 1 plus 5. Okay, now if you want to calculate the voltage gain, okay, AV equal RC divide R prime E. Let's see. 1 plus 5.
Point 127.
Which one you want? This
A
one here.
voltage,
RC equal, what is RC equal?
0.83.
Okay, perfect. 0.83 ohm or kilo ohm. That will be K ohm. And the voltage gain equal 0.83.
Over 6.8, which is 0.1266. 0.1266.
Divide. So, yeah, just a minute. I get 126.
Yeah.
That is the gain. And if you want to calculate the V out, will be take the gain time V in. So 1260 millivolt or 1.26. Okay, so that is completely calculation. If you can understand, you will be engineer someday.
Where did you get the VS number?
VS
From the RIN input.
Oh, there it is. Okay, sorry about that. Gotcha.
Okay. Now we go. CC amplifier. Before we go to CC amplifier, I want to tell you the one you learn, CE, CE amplifier. Okay, CE amplifier. That means 8 meter will be common. 8 meter will be brown, common. That's why they go CE. And now you go to CC. That will be telling you collector will be common. CB, that means the base will be common. Common, okay? So, CC amplifier, get another name, 8 meter follower. So either they say CC amplifier, or they can say 8 meter follower. And that's why they're telling you here, collector is at AC route. Common 8 meter. That means 8 meter at AC route. Same thing. Common base. Then the base will be AC route. Next will be a stable voltage gain. They get a high input impedance and low distortion. Okay? That summarize for common collector amplifier. Now, you're looking on this circuitry. First thing, for common collector, okay, input applied to the base. However, output from admitter. Okay? And the input and the output in phase both go up or both going down. Okay? And for CC amplifier, basically the gain around 1. That means input, output will be the same. If the input and the output will be the same, how come we need this amplifier? They can telling you here. They get the high input impedance. That means input impedance here, looking into the base, and that resistance calculation will be a bigger, okay? That will be a high value. Okay? So now try to explain to you. Input here, output here, almost the same. Why we need that amplified? The reason is they get a very high input impedance. So if you connect the amplified output to this amplified, they get a high input impedance. So they're not loading the signal of the other one. That's why they need it. So when you're looking into the circuit, you know this is common collector. So that's why you see that for AC, collector connect to ground. And recognize input to the base, output from admitter. And input output will be in phase. That is DC. And now go to AC. Okay, you can see from the collector. Okay, you get one current. And that current alpha times IE, or basically beta, okay, times IB. This is the base. This is admitter. This is the admitter here. Okay, and this is the collector. For the AC, collector route. That's why they call a common collector. From the base to the admitter, remember, you get the R prime E, okay? And at the admitter here, okay, they want the output and also this is the RE. So see what they said right here. R in base equal beta time R prime E plus RE. That register adding the register here. Time beta. Okay. And R in base in equal beta time RE. Okay. And R in total. That means from the base. Okay. From the base you get R1 parallel R2. Same thing. R in parallel R2. And also parallel R in base. And R in base equal beta times RE. Okay? And now output resistance. That means you're looking into the amplifier. That's what they call a G out or output resistance. And if you see you're looking into that, this capacitor will be shorted. They're telling you RE, RL in parallel. So that's why they're telling you right here. Okay? Output resistance, RE parallel RL. And also they given you the gain, AV the gain, equal RE. Okay? Divide R prime E plus RE. Okay? And the other one, V out, AV times V in. Do we get? Okay. That one. Last calculation. First thing, take one VB. Try to understand for the bipolar transistor amplifier. And later on you learning the FET. That will be more easy for you to understand. We get two different transistors, bipolar NPN, PNP. And later on, the FET. Okay?
For this particular problem, is the AC and DC beta the same or different?
Same.
Okay, same.
When they not given different, using the same. at least you can go up to this point. A, B, C, D, E, F. At least you have to know how to get up to that point. Okay, who get A?
Five?
5?
Yeah.
Okay, perfect. You don't have to do calculation, right?
Mm-hmm.
The thing that you register, I wanna do the same.
4.3.
Yeah, 4.3. Very good.
4.3 again.
4.3 milliamp. Right?
Yeah. Ten volts. $5.7 volts. And 5.814.
5. Is it right?
No, 5 point.
Okay, 5 point. Sorry.
5.814. Ohms. Let's see.
Who get that? Small e.
Is that 500? Because
Okay, you get 500 ohm.
you got 1K in parallel with 1K. So since they're the same, you take half of it.
Okay, so you get 0.5.
500 ohms or 0.5K, whatever you want to call it.
0.5K, right? Or 500 ohm.
Yeah, same thing.
R in base, beta times RE. 175 times 1, right?
175 times 500. There we go.
Number I1 parallel I2, parallel R in base. This time, I see that this program, this class very good to me.
Letter I has got to be less than 18K.
So what you get answer?
Let me see, hold on.
I think I want the answer. So for the student, they need to go over to the web, then they can do it.
Can you show us how to do RN total? I'm a little bit, I don't know.
Yeah, that's
Maybe
what I
it's-
was asking about.
Maybe it's the double lines. I don't know why, but I just can't wrap my head around how to do that.
Well, what that is, that's R1 in parallel with R2 in parallel with R in base. So it's 1 over R1, 1 over R2,
Okay, that's.
1 over R in base.
Okay, thank you. Um,
And what you know about parallels is when you got 1 over R1, 1 over R2, 1 over Rn, if R1 is 18K, R2 is 18K, and Rn base is 175K, the answer has got to be less than 18K because when you do parallel, it's always smaller than the smallest.
So, Mr. Smith, you get the answer?
I gotta put it in again, Mr. Pham. I hit the wrong button. Somebody else get it?
I already given the formula. You couldn't get it, that's really a problem.
Wait, hold on. It's not it's not a problem. Just got to hit the right button.
0.56.
I got 8,559. Is that what you got, Mr. Pham?
No, I'm not doing calculation.
Oh, okay. Did anybody get 8,559.782609?
8,000.
Yeah, in other words, that's 8.559K.
I got the same answer.
8.5559K. 0.5 and then a 9, then a 9. No, you got 8.559.
Okay.
K. There you go. That's it. That's it right there.
Okay. Next one. AV. RE. RE 0.5K. Divide R by E. Let's see.
R prime E is 5.814 ohm.
What you get? AV.
Okay, hold on. For AV, I don't know if anybody else got this. I got 0.9885. Did anybody get that? That'll be the voltage gain.
Oh, I
A
got,
different,
yeah, I got 0.1467.
the same answer as yours, Lisa.
I must have hit the wrong button again. Yeah, the gain, I got 0.9885, which is basically almost like 1. I got what you got right there, Mr. Pham.
Yeah.
Did anybody else get that?
Uh-uh.
For the AV, 0.99.
No, I didn't. Hmm. I'll have to take a look at that.
Okay, so little RE, which is 5.814.
Right.
Mm, mm, mm.
Plus RE, which is 1 kilo ohm. And the RE on top is 1 kilo ohm. Hmm.
No. The R prime E is 5.814 and RE with the little e is 500 ohms or 0.5 K.
Oh, I was looking at the wrong RE. Okay. Hmm.
Yeah, I checked it, Mr. Pham. I agree with you. The AV is basically 0.99.
Yeah. Okay, now summarize. You see input is 1 volt. I am at
That's
output,
VAC.
output 0.99. When I am at output the same. Okay? So common collector. Input output were only almost the same. However, what you have to memorize is what input impedance will be high. R in bed right here. We calculate, we get 175 kilo ohm. That's what we need to know. Input output, same phase. Both go up, both going down. And the gain almost equal to 1. Input output almost the same. Only the difference will be input impedance is very high.
Hey, Mr. Pham, since the
Yeah.
input impedance is very high, what did you say it do to the output? What effect does it have on the output?
No, they don't care about the output.
No, I'm asking you what effect, since it has because one thing we know in electronics or electricity, resistance is the opposition to current flow. So if you have a high input impedance, because impedance is basically like ohms or resistance. So
Right.
if you have a high input impedance, what does that do to the things on the output?
Now I telling you. If you get another amplifier, connect into this amplifier. Okay? So this amplifier, they get a very big resistance. 175.
Right.
That means they're not loading signal coming out from the other amplifier. If this is small, that means they loading down. That's what they don't want. If they need amplify, they using CE, common amp meter.
Yeah, but my question is, I understand what you're trying to say, Mr. Fan, but my question is, when you got that high input impedance, what does it do to the output?
Now it doesn't matter. The only thing is they don't want to loading down. The signal go into input here. If you get this resistance is small, so this signal will be loading down. They don't want that. Nothing to the output.
Yeah, but my point is your output big, small, medium? What?
Now, same thing. I already telling you. This common collector, input, output, on mode, the same.
Okay, okay.
Only the purpose is they get a high input impedance. So they're
Okay.
not loading down any signal. Go into the input.
That is
Remember,
that is a signal coming from another part of the circuit coming into this circuit.
right,
Would get loaded down.
exactly.
Okay. All right.
Okay, I think that's good enough. We left over on the common base. So next meeting will be finished that.
Sounds good.
Okay, any question? Anything?
Next meeting is next year, right? No, I'm just kidding.
Okay, if it's not, I wish all of you will be get a very good holiday.
Oh, Mr. Pham,
Thank you, you too.
Mr. Pham, did you do those updates?
Update what?
Like on one of your labs, when you put in the answer, to make it pass, you had to put in the wrong answer.
Which one you talking about?
I think for Tech 1, I think it was 11. Where you had
11, assignment 11.
where you had 3 circuits. One of them, you need to check. I think it's assignment 11, and I think one of the when you take the measurement, I don't know where you got your measurement from, but I believe it's the wrong one. And
Okay.
when you did your Excel, you typed it in, and it makes everything come out wrong
Okay, I
or
think
fail. And then the last question, Mr. Pham, this doesn't affect this class. This is just me on the D Lab 2. You changed that to PC.
okay. They left you. I already
Update.
updated.
Okay, thanks. That's it. Thank you.
Yeah, you're welcome. Okay, so good night, everyone.
Good
Thank
night,
you.
Mr. Pham. Thanks a lot, Mr. Pham.
Thank you.
Yeah,
No
thank
problem.
you. Bye-bye.
Good night.
Good night.